I don't know, dude. Here we go.
Welcome to the HACKADAY podcast. My name's Mike Stish. I'm editor-in-chief of HACKADAY.
Hi, I'm Elliot Williams. I'm managing editor of HACKADAY.
This is episode 141. Today we're talking about LowFER badges, Outrun clocks, Dichroic lamps, and piano action. I'm excited to have our second keynote speaker announced for Remoticon. It is Jeremy Fielding, who we have talked about on this show numerous times for his excellent YouTube channel that explores all great things involved with mechanical engineering.
He is so good. He is so low-key and down to earth, but at the same time super knowledgeable and works through all of the mechanical motory details. I am totally stoked that he is giving a Remoticon keynote.
Well, the thing that stands out in my mind is the first time that I realized that the stuff he was doing was awesome and I really should pay attention to every bit of it was when we talked on the podcast last year about that dynamometer that he built from a second motor, like hacking the second motor to be a brake and to characterize the motor he was trying to figure out what its properties were. And just looking through that video, and I even went back and watched it again, when I was talking to him about keynote possibilities, and it's glorious. And he's gone on to do, I think the really impressive thing now is he's built this giant robot arm that we covered at least a couple times on HACKADAY, which is an amazing scratch build. But all around, I'm just excited. The talk that he's giving is on making things move. And I think it's kind of aimed at the people who aren't already mechanical engineers but need those skills in their everyday hacking.
He's one of my favorite YouTubers for his ability to explain stuff. If you want to learn about mechanical things, motors, and making stuff move, I'm sure you'll dig it.
Other thing that we saw this week is that Tom Nardi went to VCF East. This usually happens in the spring, I want to say March-ish. But it was difficult this year because of the surge that was going on, and so they rescheduled it for October. Tom was there. He said he had a really great time, and this is the first of a few articles he's going to be publishing. If you're into vintage computers, go see all the stuff that he found on his first round of the InfoAge Center for that event.
I thought it was super fun to see how many of the things he saw there we'd covered already as HACKADAY projects, and I'm sure he's got new ideas coming up. He must have seen who knows how many awesome things there that he's going to have to write up in the future.
Yeah, the one that caught my eye was that Weather Channel hardware.
Yeah, right? He got to see that in the flesh?
Yeah. Now, I have not, this is interesting because I had not heard of the Cursed Mac before. And then I think it was somebody in the writer's room was saying, have we really not covered the Cursed Mac before? And I don't think we had. So maybe we need a Cursed Mac story.
Right on.
This is a journey into sound.
What's that sound?
What's that sound?
This week's sound is one I've put off using for quite a long time. Let's see if I can get it.
It sounds like a music box.
Mm-hmm.
I don't think it's an ice cream truck.
Probably not an ice cream truck.
Guessing that it's the first thing ever recorded on an Edison cylinder.
Oh, that's a nice guess.
Is that a good guess?
It's a good guess for sure.
But it's wrong.
It's wrong, yes.
Oh, okay. All right, so don't guess that if you're listening.
Nobody guess Edison cylinder. I'll tell you what, I wanted to run this one forever and ever, and it would have been too obvious if I'd done it otherwise. Listen to this music and let it percolate in your brain and see if it stirs anything up in you. Maybe you'll get it, maybe you won't.
And if you do get it, go to the show notes, which you'll find at hackaday.com/podcast. There will be a link to a Google form for What's That Sound. Tell us your email address, the name you would like to be called on air, and your answer. And next week, we will reveal what that sound was and draw randomly from the correct answers. And whoever is drawn will get a free HACKADAY Podcast limited edition t-shirt.
Which brings us to the hacks.
The hacks. Oh, that's me. I'm up. And while we're talking about music and music boxes, let's talk about 3D printed piano actions. I think
Let's.
action is the right word for it. So the action is the mechanism that is attached to the key on a piano that you would press. And I think most people have kind of seen what's inside of these keyboards, but haven't really dove into it. And so this is the perfect opportunity. I have, I guess, a special background in this because I've been really involved in music my whole life. And then when I was in grad school for music, I shared an office with the piano tuner and got to see all kinds of things all the time. And so I was like, hey, 3D printed piano action is a great time to talk about this topic that I love. So there's not a ton on this video itself. You get to see the assembly of the 3D printed parts, and they're kind of all there, but it's not really being explained on, this is a mechanistic YouTube channel video. And I don't think the models were shared, which is too bad because I think this would be really a fun project. Yeah. But I did take this time to go out and look for a couple of different videos. Did you watch this one that's highlighted in yellow, Elliot?
Yep.
So there's like about 40 seconds in, it's an online piano technician school is showing you like the different parts of the action. And in this case, what happens is you press the key, it has a lever that moves kind of an intermediary mechanism that then causes the hammer to fly up. And before the hammer strikes the string, it actually lifts up a damper that would stop the string from vibrating. And then the hammer itself strikes the string and then recoils away from it because, you know, if you struck it and then the hammer was there, that would then dampen the sound. And then there's also a mechanism, so if you don't release the key all the way, you can play it again without the damper hitting the string. So like there's this whole special thing going on. And then if that's not enough, that's just one key. So you take this mechanism with all these different parts and you multiply it 88 times for a full keyboard.
It's funny you talked about the mallets because we were playing around with a xylophone with my son yesterday, 2 days ago, and he was hitting it and like holding the mallet on the thing. And of course it goes bzzz and damps out, right? And I'm like, no, you got to hit it and recoil and, you know, showing him how to do that, right? And it's exactly the same thing with the piano. So it's got this like lever that flicks it up and then lets it free dangle. That second catch that lets you replay the note without dropping the damper on it is awesome. And that's the part that was new to me in this build.
The other thing that's really interesting, and I mentioned that I'd shared an office with that piano tuner at the music school. And when I walked into that office, here is these 88 keys and the mechanisms just sitting there with no piano to be found. And to me, I'm thinking like, how do you take the piano apart? So interestingly enough, the whole action just slides out parallel to the floor towards you. And it's,
right.
You know, it's long. It's like 18, maybe 24 inches long. And then it's as wide as the entire piano. And so there's another video here that kind of shows how that mechanism comes out. I think in the first 10 or 15 seconds of that video, you can see that whole action, piano action coming out. But wait, we're not done yet, Elliot. For the price of 2 videos, you get a third video link. Although I don't know that this one actually goes to the video because I'm guessing this is like a subscription only. But there is a superb documentary called Note by Note, The Making of Steinway L1037. This was on PBS. I don't know, what, maybe Independent Lens or something like that on PBS. But I watched this 2 or 3 times. It's so amazing. It goes through the Steinway factory in New York City, and they talk to the craftsmen and women who are making these pianos, and you show like the amazing amount of work and like unique talent that goes into these. Like these are, it's truly a craft that's being lost, and seeing something 3D printed is a great way to learn about it. But I think that you can't replace the woodworking and the mechanics that go into like the best of these instruments that have evolved over, like I said, hundreds of years.
Well, if you think making a piano is black magic, wait until you see making a microwave frequency doubler. This is an awesome video by Gregory Gusberti, All Electronics YouTube channel. In this, he's trying to make a 5 gigahertz radio source, and he's got a 2.5 gigahertz radio source. The cheap solution is then to double the frequency of the 2.5 gig input. And that's what this video is about. But it's also about his way of making kind of radar frequency circuits. And it's kind of a seat of the pants out of a fast transistor copper tape and just a lot of trial and error and pure grit, basically. In principle, the circuit is pretty simple. You take the signal in, you amplify it with a transistor a little bit too much, so the transistor starts to distort. Rounding the tops off the curves, the transistor makes these extra harmonics for you. You then filter out everything except the harmonic you want, and then boom, you've got a 5 gigahertz signal. Sounds easy, but of course everything in the microwave range is kind of crazy voodoo circuitry, and there's no shortage of that in this video. He tries to make it fairly intuitive, and I don't know, did you see that bandpass filter at the end, Mike? That's the one that kills me. It's just a few copper strips that are a half wavelength at 5 gigahertz long, and they're stuck next to each other, staggered each halfway across.
Oh yeah, I was wondering what that was. That's in the picture on the top of the article.
One vibrates the next one next to it, which vibrates the next one next to it, but they have kind of, because they're a half wavelength long, each of them has this kind of native wavelength that it wants to vibrate at. And so it's getting more and more selective for 5 gigahertz as it kind of walks down this ladder. And that's a marvelous piece of microwave circuitry because you look at it and there's no connection at all between these pieces of copper. How does the signal get through? And the answer is it's radio. Like, those are little resonating antennas all coupled with each other and selecting out only the 5 gigahertz from the output.
So I thought it was capacitive coupling. It's not?
No, they're...
Huh.
Well...
It's
one
hard to
man's
say.
capacitive coupling is another man's near field radiation. I don't.
I think my problem with this one, Elliot, is that
It's electricity,
normally
man.
we're trying to find things that make RF not look like black magic, and this 100% makes it look even more like black magic to me.
Oh, really?
Yeah.
Oh, man. I actually felt this one was one of the first times I kind of got some of this microwave circuitry. Possibly the coolest thing here, and this may be for the people who are more radio nerds, is the quarter wave stubs on the collector. Like, you see he's got a transistor, and then the power going into that transistor, he wants to block the 5 gigahertz from going back up and into his power supply. One way to do that is that if pieces of copper that are a half wavelength long vibrate at the right frequency, pieces of copper that are quarter wavelength long hate to vibrate at that frequency. And so he uses one to let the DC voltage through, but block the AC 5 gigahertz voltage from creeping back up into his power supply. There's a lot of great little details in here, but I think what was most inspiring for me in the end is the way he made this physically, fabricated it, is dead simple. It's a one-sided PCB, and he's literally taking pieces of copper tape, cutting them to just about the right length, and you can see it in his bandpass filter. When he doesn't get it quite the right length, he tapes a little bit more copper tape on there, solders it together, and then plugs in his power meter and trims it until it gives him the maximum power, and he knows it's tuned up. Like, on one hand, this kind of empirical circuit design stuff, like, he knows his RF, he knows his microwave RF theory, don't get me wrong, but that's a different thing to actually making it and making it work yourself. And to make it work yourself, you do need a little bit of instrumentation. And so, he's definitely got an RF power meter that runs at 5 gigahertz. That made me think, how would I do something like this? So I went looking around on eBay for like $40. You can get a 5 gigahertz capable power meter. It's probably not professional gear, but like, it's rough and ready. It'll get the job done. You could follow in this guy's footsteps.
This next one is a good example of something that totally exists but shouldn't. It has no business existing in the world right now. It's an article Lewin wrote entitled "Hacking an IKEA Lampshade into a Stunning Dichroic Lamp." It's a project that Raymond Power put together, and I kind of went down the rabbit hole of Raymond Power's projects, and it was really a delight. But the first thing that you should do before even trying to conceive of this in your mind is go find it on HACKADAY and look at the images at the top of this. Elliot, tell me those don't look like renders.
It looks pretty cool.
But does it look like something you would actually see sitting in front of you?
It looks like it's set up in some kind of weird photo studio where they have a million different colored lights and they can make it look like it's from outer space.
Yeah, or it looks like a glitched out oil slick with a bright light shining on
Squared
it.
off, glitched out oil slick.
Yeah, so
Good.
it is actually nothing more than a downlight
It is,
turned up
actually.
and then a lampshade. It is oil. It is an oil slick, isn't it?
This is exactly what makes oil slicks do their thing. But keep going.
That's funny. I didn't think about that.
You got the physics damn right.
Yeah, so it's just a film of dichroism, which I had to look up because I had not been familiar with this. And the definition of that word is going off the edge of my screen. The definition of that word is a property possessed by many doubly reflecting crystals of exhibiting different colors when viewed in different directions. And in this case, you just get the lamp that already exists from IKEA that's super boring because it's kind of got this material in it, but it's not the main part of the lampshade. But then Raymond takes it and takes that material out and lays it flat and then starts cutting and folding so that you get a voxelated cube, which just means like a cube made up of other cubes. And this cube has rounded edges. So you end up with like a red cross shape on the top and on each side of it, and then there are like intermediary cubes that blend those edges between those cross shapes.
It's an absolutely beautiful design. Really takes maximum advantage of this film. And I saw that and I'm like, dude, where do I get crazy blue-yellow dichroic film like that?
So someone in the comments said you can just get the film online and then you put it on like a plastic backing. And so if you can get it onto the plastic backing without bubbles, I bet you get just as good of effects as this.
Now, I won't lie. I've got a set of dichroic mirrors down there in my junk drawer. And I'll tell you why. Because they're exactly what you need if you want to make an RGB projector out of 3 different light sources.
Ah.
The gimmick is you put the mirror on the 45 degree and like you shine the green in from one side and it bounces upward. And then you shine the red in from 90 degrees and it passes straight through, right? And so you can use these to combine 2 different beams of light that are different colors. You can get them in old projection TVs because they would have 3 different RGB light sources behind 3 different lenses all combined with these things. So like the really super old school projection televisions, rear projection TVs, not only have these giant Fresnel lenses that you can burn anything with, but they also have a bounty of dichroic mirrors in them. And I was messing around with RGB lasers for a while and using them to align the 3 beams out of that. And they're worth their weight in gold as far as I'm concerned.
Now, I'm probably not going to play around with the film itself, but like I said, I went down the rabbit hole with Raymond's projects, and he previously built this shape in an opaque papercraft project called the Paper Voxel Sphere.
Yeah.
And so you can see exactly how it's built, and with just a ruler and a hobby knife, you can build one of your own for your own desk.
Let's talk hardware emulation for a second here. This next hack is Arduino Nano Floppy Emulator for when your floppy disk is not accessible. This is a great project by Acemi Elektroniki. This is exactly what it says. It's an Arduino floppy drive emulator. You take an SD card that's loaded up with a bunch of floppy drive images, plug it into the Arduino, plug a whole bunch of lines from the Arduino out into an old floppy drive cable, and the Arduino knows how to receive the motor commands and pass the data back to fool whatever computer you have it connected to into thinking it's talking with a real old school floppy drive. These are awesome if you have some old gear and you are just tired of floppies because they're a pain in the butt. But you can also fit like your entire software collection on one SD card. There are products on the market, like I have some Gotek floppy drive emulators in some gear of mine, but it's not nearly as cool as this one because he also outfits it with an I2C OLED screen so you can see what the files are and which drives have what on them and select through them with a menu that he made. To make it even more user-friendly, he's got a serial terminal for it. So you can hook it up over serial to the computer that it's emulating the floppy drive through, pick which disk out of your SD card disk image collection you want, select that, queue that up, then you can read out of it just as if it were a floppy drive. This is an awesome solution for anyone who's stuck with the old floppy drive conundrum and wants to get out of it. And the fact that you can do it for the low price of what? An SD card module, an Arduino, and an optional OLED screen. Please, that's so awesome.
Yeah, and then this is just showing it on a slice of perf board. But if you have a setup going like your altar to the retro computing gods, you can certainly build this into something that looks more appropriate to that setup. And I was even thinking you could hide the interface and use something like maybe fiducials on floppy disks. So you could have like a gutted out disk drive that this just lives inside of, and different user interfaces are how you could change what's on the drive.
Oh, that's a fantastic idea. This has all of these little like hacker touches. He ran out of Arduino signal lines, so he had to figure out a way to connect the 5 buttons on one pin. And he uses my favorite resistor ladder into an ADC trick. So which button you press sets up a different voltage on the line, and that's how the Arduino knows which button's been pressed. I was scratching my head for a sec thinking, haven't we seen an Arduino floppy post recently? But it was the other way. It was
really
writing a floppy drive controller for an Arduino so that you can plug a floppy drive into an Arduino and load data into the Arduino. And because this is the way HACKADAY works, Acemi Electroniki actually used Arduino FDC's code in making his device that then would talk to an actual floppy disk controller. So
oh, no way.
It's
I love that.
all one big hive mind of awesome hackery.
Oh, I'm glad you brought that up. I totally missed that part of it.
And last, if you are in the situation that I am, where you have one of these Gotek emulators already, you should look into the open source Flash Floppy project, which takes the kind of lackluster firmware out of the Gotek and replaces it with something much more flexible, fits every machine, uses a lot more images, significantly easier to handle. Go check out Flash Floppy if you've already got a Gotek. But if you don't, this would be even better, cheaper, and hackier.
Elliot, the internet is all about checkboxes.
Oh, dude.
I think we should just stop doing our full graphics and just start sending bits across the internet and having to play it on checkboxes. That's the case in this web-based Doom that is using a 100 checkbox tall by 160 checkbox wide display surface to show the game playing. So you basically have a black or white screen made of checkboxes that you can play in your browser live, although it did crash my Firefox. Did you try to play this one at all, Elliot?
No, I didn't.
Yeah, it crashed my Firefox, and they warn you not to use Firefox. They say that like Chrome and Edge is the only thing that it's going to work on. And they say it's because of some CSS stuff that I think I'll talk about in a minute. But I did open it up on Chrome, and it runs on there, and it runs great. Like it did not load my system down or anything like that. You kind of have to see it to believe it. But for me, I can't believe that we didn't run an article about Checkbox Land, which is the project that this is built on top of, which is putting a page with a huge grid of checkboxes on it and then using JavaScript to draw different things by which checkboxes are selected or not, and then also to interact with it. There is a demonstration where when you click on a box, it does like waves in a pool going out from it. And for some reason, I just saw it playing Doom. I should be impressed from that. But the interaction of the full-size checkboxes, clicking on it and seeing that animation kind of made my eyes light up.
It's the checkbox version of ASCII animation, and it's absolutely hilarious. There's an AA lib which will let you do the same thing with, ASCII on an ASCII terminal. And this is that, but checkboxes, CSS, and Web 3.0 or whatever.
So the CSS on this, the reason it doesn't work on anything else is that they're using the Zoom CSS descriptor, which I was like, why don't I know about the Zoom CSS descriptor? It's because it is not part of the standard CSS and it only works on a few browsers. There is some one on Mozilla that works as well that's not just an easy, keyword like that. I'm not sure. I'm not going to get into that stuff. But Where I did kind of go down the rabbit hole on this one is with the WebAssembly. And I remember us running an article on Doom in WebAssembly, but I didn't really dive down into that one. Well, I went back and it did it this time. And Elliot, this is for you and me. WebAssembly lets you write C code to be run on your web pages.
Right. It's a horrible abomination.
It is. I watched maybe like an 11-minute, like, what is WebAssembly, which was a good little description of it. But it's like the C code gets compiled down and then put into like a block of static memory. And then you can access that block of static memory from JavaScript, basically. It's still something I kind of want to look at and see what the utility is there, because for me, I've done some Node stuff. I've done some JavaScript stuff. I've done some PHP stuff, which is just so unpleasant. And it would be nice if I could just, have a front wrapper with those higher level languages and then write the stuff I actually want to do in C.
Yeah, right? The thing that rubs me wrong about it is that browsers have become like operating systems unto themselves. They have their own graphics rendering. They have their own sound rendering. If Google gets its way, I think they'll have their own MIDI capabilities. Like, it's a little mini operating system that runs on your system in whatever operating system you have. And WebAssembly is kind of the last step toward acknowledging that, which is what rubs me the wrong way. Like, I want to write C that runs on the operating system I have on my computer, not for the browser that runs like its own operating system inside the operating system. But I think that's a losing battle. I think WebAssembly will let you do crazy ass things in the browser really fast if that's the sort of thing you're into.
So from your observations there, where we're really headed to is for the browser to end up as just like a VM server that can just download VMs really quickly. It's like every page you go to is its own operating system, its own virtual machine. Why would you
stop before writing a VM machine, before writing a VM server in WebAssembly and then putting that inside the browser? Somebody's going to do it. And then somebody's going to write a browser to run inside that VM, I hope. And if that runs WebAssembly, I'm happy.
Yeah, then you hook the end of one into the beginning of the other and it eats the internet.
Then the whole experiment was worth it. My last hack is a mic hack. This is ESP32 clock, pushes Outrun graphics over composite. This is a lovely put clever things together to great effect hack by Marcio Teixeira. If you look at it, it's an old school TV, and I think his is black and white, CRT TV, and it's got some 1980s style graphics that I learned is the Dali clock old screensaver running up on that, where it shows the clock digits and then they kind of morph into each other. I guess that's the Dali part. Anyway, underneath it's got that like grid that disappears into the background with the sunset. It's a lovely piece of retro eye candy. This one runs on any display that is composite video capable.
Which is like none these days.
Like nothing at all. Like, good point. No, it's actually all the cool stuff, but that's for a different day. This is based on an ESP32, so it's got access to NTP. So this is actually a retro crazy clock that can keep ultra precise time. It uses only 2 pins on the ESP, so that's enough to send composite video. It's a beautiful, beautiful hack, and it makes use of 2 other hacks that we've seen here that I really loved, so that's part of why I like this so much. One is BitLooney's software-defined television on an ESP32, where he made a black and white composite video out, and then combined this with some other work done by Rosamur on run your favorite 8-bit games on an ESP32. Now, this one is epic. This is the craziest hack of 2020, I think, actually. He got a bunch of different old video game machines like Atari, and I don't know if there's a Commodore 64 emulated in there, and they all spit out color composite video out of an ESP32. So you take the ESP32, plug it into an old monitor, and you're playing old Mario on the NES emulated on an ESP32. That's so rad, but that contained the secret to doing color composite video that Marcio needed to mash in with BitLooney's code and make his crazy dolly clock work in color as well.
I really wish I had had time before right now to dig into the code on this one, because,
Yeah.
the thing when I first saw it, I'm like, how are those animations running? Those animations are very cool. Like the numbers morph into each other.
Right.
And so you have to have animation frames on that. There is, what do you call it? A reflective sweep across the numbers. And
Right.
I'm interested that there must be some messing with color codes by column or something. And I just, it would just be very interesting to see exactly how those are done.
Yeah, well, if you're interested in code, you should go dig into that, because I think the version that Marcio used here was actually a screensaver written after the fact by Jamie Zawinski, and he does fantastic graphic demo coding. So I'm certain that the code that makes this work is absolutely worth your time. And if this whole thing about putting out crazy color graphics to archaic TVs in color from an ESP32 strikes your fancy, Marcio also took the color composite parts of his work, made them into a standalone library, and you can find that linked to from his write-up of this too.
First up on my list of quick hacks this week is why wait for Apple? Upgrade your iPhone with USB-C today. Jenny List wrote this one about a project by Ken Planell, and I wanted to talk about this as one of my favorite hacks of the week, but the problem is this is just a tease. So what Ken has done is he's taken the iPhone and he's ripped the Lightning port out of it and put a USB-C port into it, and we get this image of a flex PCB with a bunch of stuff and a connector on it, and you get some machining and epoxying and reassembling stuff at the end of the video, but you don't get the full gory details. So go check out what is there so far, and we're going to keep our eye on that and hopefully talk about it on a future episode. Next up, Doom played by Tweet. Brian Cockfield picked this one up about a project over on @Tweet2Doom. This is the wildest thing. It is, I guess, like a command line interface to play Doom, but you issue the commands up front and then you get to see what actually happens in the game. So you tweet a string of text in a particular schema that was developed, and then a reply to your tweet will come back with a video of the game actually being played. And then you can reply to that with the next string of stuff that you want to do, and you'll get a video back from that. And anybody can reply to anybody's tweet string. So you get this like huge tree of Doom segments that are played. And I clicked around and found one that was like 11 seconds long and actually made sense on where the character was going. It was amazing. And last up on my list, turning old masks into 3D printer filament. This is a research project out of the University of Bristol that caught Tom Nardi's eye, and so he wrote this up. It is those like blue or yellow disposable surgical masks that they must have made 20 billion of those in the last year.
Exactly.
Like, what is happening to those masks? They're plastic, so you can actually just grind those up and put them through a filament extruder and then print with that filament, and that's exactly what this research group did. Maybe don't go asking randos for their masks, but collect them amongst your friends, or like what the researchers did was they got factory rejects that were never able to be used, and they gave this a shot. It's kind of an interesting thing to do with your waste.
My first quick hack is an oldie but goodie from way back in 2016. The calls are coming from inside the house or workshop. This is a phone hack by Simplifier, and it's kind of the last step in a series of hacks where he builds a working two-telephone phone network all of his own from the ground up. And by ground up, I mean making his own strange carbon microphones, hand-winding the coils to ring the bells, etc., etc. It's a lovely hack, and you should check out the whole series. Next up, Spinning Threads put the bite on filament in this novel extruder design by David Leitner. This is the weirdest extruder. It's got a barrel that kind of spins around the filament to be extruded, and then the barrel contains 3 different angled screws in it. The screws turn and push the filament downward. Why would you want to do this? It's got a lot more contact of thread against filament, so it can push it a lot more firmly, securely down and back to make for better extrusions, better retracts, And plus, it looks super cool in action. This is crazy lateral thinking. I love to see it. Last up, the Pine Phone Pro is here, but is still probably not the year of open source Linux on the smartphone. This is Jenny's review of the brand new Pine Phone. It's meant to be a developer's phone. They hand it out to you, and it's lacking a lot of software. You have to write it yourself. Her conclusion is that the Pine Phone Pro is probably still in that sort of state, but we'll see. Hopefully it will become less and less incomplete over time, because even developers have to use their phone to call people from time to time.
It's time for our Can't Miss Articles of the Week. This is long-form content written by excellent HACKADAY authors, and the excellent author I picked this week was Ryan Flowers, who wrote one called Space Age Road Rage, Right of Way Above the Kármán Line. Now, if you're not familiar, the Kármán Line is the imaginary point where you leave the Earth's atmosphere and you enter outer space. And so we're talking about things that are orbiting the Earth, and they're just basically up there kind of doing their own thing. Ryan starts off the article with a great example of riding his bike down the street and having the right of way, but having a driver try to turn into him and having a near miss. This is happening all the time in space. It's become at least the area right around the Earth has become a very crowded area, and all signs are pointing to it becoming even more crowded as time goes on. There are a couple of different companies who are in the middle of efforts to put up tens of thousands of satellites to make swarm networks. The one that comes to mind most commonly is Starlink. As we get those into space, the likelihood that they're going to slam into something else becomes a lot bigger, and we run into this problem of what are the rules up there? Do we even have the ability to establish what satellites should be able to move to make way for other satellites, and how the different entities involved communicate with each other when these events are about to happen?
And the answer to are there any rules is no. It's totally the Wild West up there. And there are kind of conventions, and these were maybe arguably better followed when there were a smaller number of firms, a lot of them also government agency related firms, working with each other. And so you don't want a Russian satellite to crash into a US satellite because that's an international incident. But if everybody is just different companies, who's going to yield to whom up there if there's no rules? And how do you know to call the right people? It's not as tight-knit a group as it used to be in a way. And the other place that I can think of where there's kind of looser rules than driving around on the street is the open ocean. But even there's kind of established rules of right-of-way, and, the smaller, more maneuverable ship has to get out of the way of the bigger ship and things like that. There's none of that in space at all. International rules for ocean faring must have developed over time because there were enough crashes that they're like, hey, we got to sort this out. And what do you think? Is that what's going to happen in space?
Yeah, I do think it is. One of the interesting points that Ryan makes in this article is that there have been, notable events where satellites have, crashed into each other. And when they do that, they leave a cloud of other debris up there. So back in 2009, Roscosmos's 2251 satellite crashed into an Iridium 33 satellite. I don't know if it crashed into, but the two of them collided in space, and the combined velocity was 42,000 kilometers per hour. That's 26,000 miles per hour.
Ouch.
And if you think about what goes into that, and then think about when you have a fender bender, all the stuff that falls off of your car, right? Well, you're going to slam two satellites like that into each other at those speeds. You're going to have this huge, expanding cloud of basically more smaller satellites that are themselves traveling at high velocity. This is going to become a problem. The other thing that kind of really was surprising to me is Ryan talks about Vanguard 1, which was a research satellite launched in 1958. It's still up there. They lost the ability to control it in 1964, and it will not deorbit from its natural decay of its trajectory until 2198. Woo-hoo. And so just not making the problem worse is a huge part of this. And, Tom actually wrote an article recently about some research into satellite tails.
Yeah.
Like it's like a very thin film. It's like a fruit roll up, or what was that? Fruit by the foot. It's like a very, very thin material that's rolled up like fruit by the foot, but it can unroll to be something like, oh, I want to say a quarter mile long, but I don't have the number in front of me right now. And it just adds a little bit of drag that will pull those satellites in low Earth orbit back down towards the atmosphere so that they can deorbit faster. But even if they, lose control of the ability to adjust their position, these, like the Starlink satellites, are designed and put into orbit to deorbit naturally in 5 years. So that's a lot better than that Vanguard 1 example.
That brings up a kind of differential responsibility and willingness to lose a satellite problem that I think we've got between the different companies and agencies that have stuff up there. When my mom was a grad student in New York in the 70s, she had a beat up old VW Bug. And that meant she had right of way because she knew if she crashed with the other car, like it would be $20 worth of damage to hers, and their extremely valuable Mercedes would get the worst of it, right? Like in New York, when it was the Wild West, it was the cheaper car has right of way. And I think that's the case in space right now because Starlink puts many, many, many satellites up there, and they put them up there with essentially a 5-year lifespan. And then you think of something like it's in a totally different orbit, so this cannot happen. The Hubble Space Telescope, right, which has been up there for 30 years. It's an extraordinarily expensive piece of observational equipment that still has tremendous value. So if the Hubble's on a collision course with one of these SpaceX's, and the Hubble people are like, there's a 1 in 1,000 chance of these things colliding, can you please divert? And the SpaceX people are like, only a 1 in 1,000 chance, no worries, we'll let it go. So there is this kind of asymmetric incentives and feelings about loss of satellites up there. And that, I think, will probably require some sort of greater overarching global regulation to handle.
When you look at space, I think it's going to be more difficult to come to agreements on what regulations will work for everyone. And then it will also be hard to enforce that because you have satellites up there from, a dozen different nations, if not more. And you need to get all those nations to agree to it, or you need to get all of the companies to have buy-in for it. And I guess that's where we're at right now, is we haven't solved that problem.
My can't miss hack this week, the lowdown on long-wave, unlicensed experimental radio, is a great write-up of the radio band You Don't Know About by Adam Zaloof. This is mostly talking about LowFER band, which is super low frequency radio. It's 160 to 190 kilohertz. It's so low that you can almost watch the electromagnetic waves vibrate. It is way down there on the bottom, and because it's not used for very much, was given an experimental license in the United States anyway. And it's very loosely controlled. And the rule is basically don't put more than 1 watt into the radio, and anything else you want to do, go nuts. You can do it. You don't need a ham radio license. You don't need anything. It's for experimentation. And if you can see my air quotes, that's me trying to say this is a band for hacking around in.
So we talked about this before. What would it take to set up a hacker network of LowFER stations?
Not a hell of a lot. And that's what's lovely about this. I'll throw in an article by Jenny List from a few years ago, Get Set for SAQ on Alex Anderson Day with these active antennas. And so that's what you need. You need an active antenna, which can be as simple as a small plate of copper-clad and some kind of JFET to amplify it. Because these radio frequencies are so low, you can feed the output of this amplified antenna directly into the sound card of a computer and demodulate them using your computer. You don't need an SDR. You can do it on your computer's sound card.
Oh, it's such a sad thing that we're not in person for SuperCon this year. Wouldn't it be awesome to try and get a bunch of people together ahead of the conference to build like a text messaging network on this.
LowFER badges.
Yeah. Oh, LowFER badges.
Oh.
Oh, can you imagine?
Oh, that's good. So the gimmick with these antennas, I actually went looking these up because they've puzzled me for quite a while. The most popular one is the mini whip antenna. And like I said, it's a tiny little scrap. I mean, it's, a square inch of copper-clad board. And if you think about the wavelength of 160 kilohertz, it's how many miles long? I don't even know. But if you wanted to make a tuned antenna for this thing, it would be miles and miles of copper wire. And the gimmick with these mini whip antennas is they're not trying to catch the signal at its natural resonance. Instead, they're just trying to catch any of it. And so you don't need to worry about tuning the antenna to separate the signal from the noise. And this frees you up to just crank a big amplifier at it and hope to see the difference between the signal and the noise there, which makes for a super compact, super easy to build antenna. And this is super timely because this weekend, Sunday, Alex Anderson Day, they are transmitting for UN Day on October 24th with this crazy old transmitter from like 100 years ago that predates vacuum tubes, predates transistors. It actually transmits radio waves by having a huge spinning wheel that makes sequential contacts. So the thing looks like a 19-teens power generator, except it's making and breaking electrical connections so that it makes these radio waves and transmits. And they only fire the thing up twice a year. It's coming on this Sunday. And especially if you're in Europe, you could receive it easily with your computer sound card and a mini whip antenna, which you can make out of parts in your junk box. You can do this before this weekend. They're testing it out, by the time this podcast airs yesterday. Okay, you're going to miss the test, but you can, if you build yourself a mini whip, you can listen in for the real deal on Sunday.
That's all the time we have for this episode of the HACKADAY podcast. As always, we'd love to hear from you. You can leave a comment on the show notes. You'll find those at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you do something cool or see something cool, please let us know. tips@hackaday.com. And until next time,
keep on hacking. How am I going to pronounce this? What do you think?
I think it's Arduino. I even already wrote a title, Elliot.
I think it should be hot piano action.
We probably shouldn't, but it should.
And that would probably be sophomoric. We're professionals here.
I had a really weak first clap on that one.
Damn it. That's such a good way to end.